So question 107 says determine the point of intersection of each pair of lines if one exists. Be sure to record your progress on your paper and check each solution if possible. So let's start with A. As I look at this, I say almost immediately I'm going to use substitution. The reason why I'm going to use that is in the first equation we have this expression negative 2y minus 3, and we're told that that's equivalent to x, right? That it's x. So I'm going to replace this value of x, right, the 2x minus 3, I'm going to put that into the second equation, right, because this entire thing is equivalent to x according to the first equation. So I'll rewrite it, and I get, so what we're doing here is we're rewriting the second equation, right? So I've got 4 times y, but then you can see I'm going to have the opposite of, now in parentheses, I'm now placing this x minus 2y minus 3. Okay, all of that is equivalent to x. And then on the other side, we've got that equals 9. So 4y and then minus x, and you can see these parentheses are everything that x is, and then that equals 9. So I'm going to use the distributive property to distribute this -1 factor. I'm going to push it into the parentheses here. This gives me a 4y and then positive 2y and positive 3, and that equals the number 9. If I combine like terms on the left-hand side, I do get 6 times y, and I'm going to subtract 3 at the same time. 9 minus 3 is 6, so 6y is 6, therefore y must be 1. And now that I know what y is, I'm going to go ahead and place that into the first equation because it's so generous. It's saying, hey, if you want to know x, listen to me. X is the opposite of 2 times y, and you can see I'm placing my 1 there, and then minus 3 from that. So x would have to be, not y, x would have to be -2 minus 3, which looks like x is the number -5. So my solution is the point x is -5 and y is 1. And it says check this answer if you can. And of course, you can plug this value back in and verify that the left and right hand side are the same. I think I'm going to check it by graphing, though. So I'm going to choose to check this using my favorite piece of free software, GeoGebra. So I'm going to, oh, I lost my equations. Where'd they go? There they are. I'm going to go ahead and type each of these equations into GeoGebra and see what I get. So in the first case, I'm going to go ahead and write x equals -2y minus 3. So I just hit in the input bar there, x, and then I'm going to say x equals, yeah, and then -2 times y, and then I'm going to subtract from that 3, and I'll graph that function. There we go. And then the other one is 4y minus x equals 9. So we'll just go ahead and push that through. 4y, and then subtract an x, and that should equal 9. So 4y minus x equals 9. And I'll graph that function. And you can see when I graph it, there it is, right? The point that I think was the solution. I think there's supposed to be a pen. There we go. So you can see that point is x is -5 and y is 1, and that's exactly what we thought it should be. So right here is our solution, and that is the point where x is -5 and y is +1. It's kind of hard to see that. If I right-click this, I can say, whoops, I gotta have this tool on. I could right-click this and I could say show the grid. So you can see when the grid's on, it's definitely crossing right through there. So definitely that solution checks because it's definitely the point where those two lines intersect. So that's one way to check a system. Let's move on to part B. Part B, another system here. This is a prime candidate for elimination, right? Because we can already see that our x terms, right, in the first equation, we've got a positive x, and the next one we've got a negative x. And when I combine x plus negative x, that's 0. So let's go ahead and just do this elimination method. I'm adding equal sides to each side of this top, equal values to each side of this top equation. So we get that 7y, 5 times 2, or 5y plus 2y is 7y equals 7. Oh, what is this y being 1? Y was 1 in the last problem. So we get that y is 1. And now if I'm going to solve for x, right, I need to plug this value of y into one of the equations. I'm going to choose the top one. So when I plug in y there, I have the x and then plus 5 times y. Y was 1, and that equals the number 8. So x equals 8 minus 5, or 3. So our solution here is 3 comma 1. And I guess this time I'm going to check it by go ahead and plugging those values in. So in the first equation, you see I've got 3 plus 5 times 1. And I need to see if that is indeed equal to the value 8. And yeah, 3 plus 5 is definitely equal to 8. So because these are equal to each other, it definitely works in the first equation. Now let's check the second equation. The second equation says take the opposite of x. So I'm going to have negative 3 and then plus 2 times y. Y again is 1. And see if that equals question mark, sorry, see if that equals the number negative 1. Well, yeah, negative 3 plus 2 is negative 1. So negative 1 is negative 1. So it checks in the second equation too. So definitely the point x equals 3, y is 1 is the solution for part B. And then the last equation here, I guess we'll go with substitution. As I look at this, I can see that this, according to the second equation, is y, right? It says y is that. So I'm going to push that value of y into the top equation. So that equation will become 4 times x minus 2 times the expression 2x plus 10, and that will equal the number 5. I guess using the distributive property, I get that 4x minus 4x, minus 20 is 5. And if I simplify, because those are the same thing, I get this expression negative 20 is 5. So we've seen this before, and my suspicion is that these are parallel lines. In fact, I'd like to look at that. Okay, so let's go ahead and take a look at that. I'm going to enter both of those equations. So in the first instance, whoops, get back up here. View, I need this keyboard. Go to my input bar, I'm going to get 4x minus 2y. So 4x minus 2y, and I'm going to, that has to equal 5. So there's one equation, 4x minus 2y equals 5. And the other equation is y equals 2x plus 10. Actually, yeah, let's see. Y equals 2x and then plus 10. Sorry, I'm slow at this. Why can't I see addition? Oh, there it is. Plus 10. And let's graph that. And, I suspect this looking at it here, but I believe what's going on is these are parallel lines. And kind of to confirm that, I do want to look at a couple points, right? So if I look at this point, for example, and this point, I can see it's up 2 over 1. So I've got this rise 2, run 1. And I can see the same slope pattern, I guess, looking at... That's difficult. I actually don't see a place where they're intersecting nicely. I can move it, but well, that's okay because I can rewrite the equations and convince myself that they're the same. But they certainly look parallel to each other, and if I zoom out a lot, I mean, looking parallel is not the same as being parallel, but I think I could convince myself that they have the same slope. So if I look at that first equation, the slope is 2. And if I look at the second equation, I rewrite that with y by itself. I have negative 2y equals negative 4x and then plus 5. And if I divide both sides by negative 2, I get that y is a positive 2x. Yeah, negative 4 divided by negative 2 is positive 2x. And then minus 5/2. So yeah, they both definitely have the slope pattern of up 2 over 1. So they are parallel lines, and therefore they don't intersect. There's no solution.